Hello everyone, welcome to Unacademy. So before starting today's session, I would like to have the input as well as the concurrence regarding the quality of video as well as audio. If it has been perfect, just write perfect over the live chat and then we are going to start the today's session. Let me focus over the important terminologies which we are going to learn in today's class and what would be its weightage in GATE examination. In today's lecture, three important terminologies we are going to learn, and they have been the existence of a limit, existence of a continuity, and the existence of a differentiability at certain point over a function which carries one independent variable. So as far as the topic of concern is being my basic, so here I am going to discuss about the existence of limit. So I would be focusing over the limit first. Once we are done with the limit, we will also be discussing over continuity. Just a minute. Limit, and here comes continuity, and the last has been differentiability. This many important concept we are going to learn in today's class. My dear friend, as far as these three terminologies are being concerned, no, they have been linked to each other. So taking the reference of a single function, I would try to explain about this all three terminologies. Agreed? And as far as these terminologies are being concerned, no, they have been very important as well as frequently asked question in GATE examination. Once we are done with the theoretical part, definitely I would also take few number of numericals which have been experienced in previous year GATE examination and few of the self-created questions. With the help of this many questions, definitely you will be able to conquer almost all concepts. Agreed? Anyways, the function which had been taken for analysis is been a function which carries only and only one independent variable. But the concept of continuity, differentiability and limit do exist for a function which carries more than one number of independent variable as well. Even it could be the function of x and y, where the z has been a function of x and y. But my basic goal or the basic area of concern is been a function which carries single independent variable. Single independent variable. If you want, I can take few number of examples. Like you can have sine of x, you can have mod of x, you can have mod of x plus 1, you can have mod of x divided by of x. This all kind of functions definitely would be categorized under a function which carries only and only one independent variable. Either you take magnitude of x, you can take another function like sine of magnitude of x, or absolute function of x. Same you can have like e to the power of minus of mod of x. Even you can take like e to the power of minus x. One thing has been quite sure, either you take the reference of either of the function, only and only one independent variable has been involved over this given function, and obviously we had been running behind a function which carries only and only one independent variable. Anyways, there have been some basic concepts behind the continuity, differentiability and limit existence, but I am not going into the mathematical or the detailed analysis of this terminology. First, over the iBird view, we will try to understand from where this concept of limit, continuity and differentiability must have been extracted. We will take around 3 to 4 number of graph, and with the help of those graph, probably you will have understanding of all case scenarios, and that would be more than adequate to smash any kind of the problem related to these three terminologies. Agreed? So let me focus on the limit first. And then comes the continuity, and then comes the differentiability. What does it mean by the continuity? See, the name itself has been self-explanatory. A function which has been a continuous at a certain point of observation or certain point of test. Let's take the test point has been x is equals to c. If I had not picked my pen out from a copy, and continuously if I have been keep drawing a curve, so obviously at x is equals to c, the function is supposed to be a continuous function. Same goes with the differentiability. Anyways, what does it mean by the differentiation? If I take the differentiation of any kind of function which carries one number of independent variable, actually we wanted to draw a tangent and we wanted to know the slope of that tangent. So until and unless you are not able to draw a unique tangent over a function at a test point, you won't be able to find its slope, and you won't be able to find its slope, that means differentiability as far as. You won't be able to get it. So as far as in iBird view, In iBird view, I can say few of the important critical outcome I can bring out of it. A function is said to be continuous. What I am saying, the function is said to be continuous. The function is said to be a continuous at any test point. Let's take that the test point is been x is equal to c. If the pen had not been lifted, no lift, non-lifting of non-lifting of pen. The pen is not been lifted. The pen is not been lifted. It's a generic understanding of a continuity. Same goes with the differentiability as well. Same goes with the differentiability as well. Same goes with differentiability as well. Differentiability. Differentiability as well. Same goes with differentiability as well. Same goes with the differentiability as well. What does it mean by the differentiability? The function must create a smooth curve at the point of interest. If it has been a smooth curve, uniquely you will be able to draw a tangent and easily you will be find its slope. Yes or no? Could you really understood what exactly I wanted to communicate over here? So until and unless the function has not been smooth at a point of interest, it won't be a differentiable at that point. And as far as the existence of the limit is being concerned, limit is bit different than the continuity. Continuity, I should not have lifted up my pen while drawing the given curve at the point of interest x is equal to c. But limit is nothing to do at x is equal to c or the test point. Limit has to do just before the test point and just after the test point. Or I should say, until and unless there had not been any sudden change, no, the function limit do exist. No sudden change, that's it, the function limit do exist. No sudden change. What I'm saying, no sudden change, by default limit would exist into the picture. What I'm saying, whenever you had this kind of problem where they had been focusing over the continuity, differentiability, or the existence of the limit, I would request to go ahead with the graphical manner. If you had a little bit idea how the graph has been looking like, with the help of those graphs, definitely you will be able to find it out whether the pen has been lifted while drawing the curve at point of interest x is equal to c, whether the function has been a smooth function such that such that a unique tangent can be drawn over at that point, and obviously that slope is going to be the slope of the function at that point. And at the same time, has it been a sudden jerk or sudden change at the point of interest? And if it has not been happening, be happy. It has been a continuous, it has been a differentiable, and the limit do exist at the point of interest. What I'm going to do over here, I'm not going into the mathematical methodology behind this theory terminology. I will take around 5 to 6 different structures of curve, and with the help of curve, you guys had to extract which kind of the function it has been, and the point of test whether it has been a continuous, differentiable, or limit do exist or not. So let me do one thing. Let me take the first question for the time being. So here comes the first question. Here comes the first question. Here comes the first question. Let's take, this has been my real axis, and this has been y-axis. This has been x-axis, and this has been y-axis. Yes. Agreed? And I had drawn a random curve. I must have been taken a function f of x, and the draw for the function f of x has been looking something like this. This has been function f of x. What I'm saying, this has been function f of x. And let's take my point of interest has been x is equals to c. X is equals to c has been my point of interest. It's been my point of interest. It has been my point of interest. X is equals to c. I would like to know from each one of you the 3 different categories which we have already discussed about it. Among them, which have been true and which have been false. What have been they? What have been they? I was discussing about. Let me mark this down. Continuity. Just a minute. Just a minute. I think I should bring this down. So let me copy this down. Copy. Paste it over here. Yes. So let me focus over this given function and tell me at point of interest, and that is been x is equals to c, whether the function do exist its limit, function has been a continuous, function has been a differentiable. My dear friend, as you yourself be able to understand, there had not been any sudden jerk or sudden change at x is equals to c. While I was approaching x is equals to c towards left hand side, that we call it left hand limit, that we'll see afterwards. And similarly, when I was approaching towards x is equals to c, I was reaching to the same point, and let's take that point has been f of c. So as there had not been any sudden jerk over here, so by default you can say, sir, don't worry about it, limit do exist at least at x is equals to c, at least at x is equals to c. What about the continuity? As the function is been smooth, that means you can draw a unique tangent over at x is equals to c. How the tangent is been drawn? The tangent is been a straight line which has only and only one intersection point with the given function. So the tangent would be something like this, and this has been a unique in nature. Yes. So obviously, if we'll talk about the existence of the continuity, yes, so the function is being found as differentiable at this point. Differentiable at this point. What about the continuity? While drawing this function f of x, or while drawing this curve, did I let this surface to come out? No, at x is equals to c, I did not left this plane while drawing this curve f of x. So obviously, the function has also been found continuous at x is equals to c. So as far as the first graph which we had taken, it had the existence of the limit at x is equals to c. The function has also been found continuous at x is equals to c, and it is also been a differentiable in nature. It is also been a differentiable in nature. What I would do at next, let me copy this down, and we will change the nature of the function bit. Let me copy this down and let me paste it over here. Paste it over here. Rub this down. Rub this down, and then let me remove this part as well. Yes. Let me draw another function which has been creating a curve at x is equals to c. Let me do so. So this has been the graph now. This has been the graph now. Till x is equals to c, the function was continuously increasing in a linear fashion, and from there onwards it has been decreasing linearly. Again, I had to perform the three tests, that has been the limit test, continuity test, and differentiability test. Tell me, out of the three number of tests which we are going to conduct with the second function, which have been okay and which have been not okay, which have been not okay, that you tell me. See, as far as the limit do exist in the concept, until and unless there had not been any sudden jerk over x is equals to c towards the left hand side and right hand side, there had not been sudden change around x is equals to c, obviously the limit do exist. Graphically, at least I can say at this moment of point, at x is equals to c, the limit do exist. As far as the continuity is been concerned, while drawing this function or while drawing this graph, nowhere I had been left this plane. So obviously at x is equals to c, nowhere I had left the pen while draw. So obviously it's been a continuous. It has been a continuous. But what had been happening at x is equals to c, you yourself would be able to understand the cusp is been formed. And as the cusp is been formed, you won't be able to draw a unique tangent at this point. And as you are not able to draw a unique tangent at this point, you won't be able to get its slope. Obviously, the differentiability test fails, or I would say it has been non-differentiable. So as far as this function is been concerned, as the curve formation has been made at x is equals to c, the function is found to be continuous, limit do exist, but it had not been a differentiable in nature. It had not been differentiable in nature. Agreed what I'm saying? So till this point, I don't find any of these students would have any kind of doubt now. Let me take another question as well. Again, I would be changing the structure of f of x a bit, and from there we will try to learn something new. See what had been happening, just try to understand this way. This has been my curve. This has been my curve. Linearly, it has been increasing. Linearly, it has been increasing till x is equals to c minus. At x is equals to c, the magnitude has not been known, and from x is equals to c plus onwards, it's been a parabolic in nature. It has been like this. It has been parabolic in nature. Let me change it to green. This has been the curve actually. This has been the curve actually. Or I can say there had not been any magnitude which has been defined at x is equal to c. So the hole is being created. What does that actually mean of hole? See, I won't be able to see whether the magnitude has been defined by the left hand function or right hand function. If the hole has been created, it has been quite known that the function worth is not been known at x is equal to c. At x is equal to c. I would like to know from each one of you, for at least this given function, what happens with the limit, continuity and differentiability at x is equal to c. What does that actually mean of limit? If you come from left hand side, right hand side, whether you have been trying to reach at the same point, yes sir, almost we had been reaching at the same point. You need not to go to the exact at x is equals to c. You will just be stopping yourself at x is equals to minus c and x is equals to c plus, and in both of the cases you had been reaching to the same point. So if we'll focus over this function, obviously the limit do exist. If we'll talk about its continuity, my dear friend, you yourself would be able to understand this function had been keep increasing linearly till x is equals to c minus, and then I had lifted my pen and I had started from x is equals to c plus parabolically, and as the pen has been lifted by default, the continuity test has been failed. And as the continuity test fails, keep in mind it won't be differentiable, because for differentiability the curve has to be not only continuous, it has to be smooth as well. But here the curve itself is not been continuous, so obviously differentiability test fails. Differentiability test fails. So I don't think any of the student would have any kind of doubt. Now let me do one thing. Let me take another curve now. Let me take another curve now. What I have been doing deliberately, I had been taking a sudden change at x is equal to c on the point of interest. So let me rub this out. So what I have done, let me see over here. You could have seen this kind of curve earlier. See what had been happening till x is equal to c minus. Let's take the magnitude is been, let's take it has been 1, and from c plus onwards it's been 2. It's been 2. If you want, mathematically I write the equation as well. So my function f of x is been 1 when the value of x is been lesser than c, and similarly plus 1 when the value of x is, sorry, it is 2 actually, 2 when the x is been greater than equals to of c. Greater than equals to of c. If you would like to draw this curve, how it would be the curve? Till x is equals to c minus, the magnitude is supposed to be 1. Yes. And from x is equals to c plus onwards, including x is equals to c, the magnitude is been 2. So what had been happening? Obviously the hole would be created over here, because the function value would not be defined by 1. Actually it would be defined by 2. And that is why the dot has been placed over here. What does that actually mean of a hole? Hole means absence and dot means presence. This means the function worth at x is equal to c would be presented by the dot, and that has been 2 actually. That has been 2 actually. So here comes the magnitude of the worth, I can say. It has been placed at 1 and this has been placed at 2. I would like to know from each one of you what had been the outcome at x is equal to c. If you'll focus over the 3 outcomes. As far as the limit do exist, what happens? If you'll start from left hand side and if you'll pretend to go to x is equal to c, or if you stop yourself just before x is equals to c, that is been c minus, you will find your magnitude is been stopped to 1. And if you come down from right hand side and if you stop yourself at x is equals to just after c, and that is been c plus, you will find your magnitude is been 2. And as there had been a sudden jerk at x is equals to c, obviously you can say the limit do not exist. Limit do not exist. And one of the important outcome also we had to extract out of it, it's been continuity and limits are been tightly coupled. How? Limit has to do from the left hand side and right hand side, nothing to do with the worth at x is equals to c, but the continuity has to do with all of 3 components. Either you have been coming from left hand side, right hand side, or even x is equals to c. If all of 3 components are being same, just before, just after, and at mid, so it is going to be a continuous. But you yourself would be able to understand left hand value and the right hand value had not been same, limit do not exist, so the continuity would not be exist. So few of the important conclusion we had to withdraw out of it. May I know what? May I know? We can make a ladder structure. We can make a ladder structure. See which kind of ladder structure I am going to make. Let me draw a ladder structure. So there have been three steps in this ladder. There have been three steps in this ladder. The first has been limit test. Then goes continuity test. And the last test has been derivative test or differentiability test. Derivative test. Anyways, what's the conclusion we can withdraw from this ladder structure? What's the conclusion we can withdraw from this ladder structure? So here comes the ladder structure. Ladder structure. So here comes the ladder structure. All the way, if you had to reach to the third step, you had to pass limit test, you had to pass continuity test, and then only you had to reach to the derivative test. If it has been said you had a function which carries one number of independent variable, let's take that function has been f of x. At a certain point of test or at a test point f of c, if the function is been differentiable, what does that actually mean of it? That means the person must have gone through the limit test, then the continuity test, then the differentiability test. That means if a function has been a differentiable at any point of interest, by default that function is going to be continuous as well as limit. Agreed what I am saying? If you want to reach at this point, by default you yourself would be able to understand you had to start from the first step, then had to go to the second step, and then had to come to the third step. So few of the important conclusion I would like to retrieve out of it. What have been then? If a function had been a differentiable at x is equal to c, the function has been differentiable, f of x is been differentiable at x is equals to c. By default, it has been continuous and limit do exist at x is equals to c. So yes, continuity test is being checked. Differentiability test is being checked. Agreed? Now in the same sequence, we can have one more outcome. Now again, we had a function over here. Function over here, f of x, which is found to be continuous at x is equals to c. If it has been continuous, by default you must have gone through the limit test, then only you'll reach to the continuity test. So I can say at least one conclusion we can retrieve. One information is already been given, the function has been continuous, so the limit has to be existed at x is equal to c. But as far as the differentiability test is being concerned, it may or may not be differentiable at x is equal to c. If you want, I can show you over here. With the help of different examples, I can show you over here. See, at x is equal to c, the function is found to be differentiable. That is why it has been continuous as well as the limit do exist. Here the function has not been differentiable, but it's still the continuity and the limit do exist. And as it has been continuous, by default the limit do exist. Agreed what I'm saying? So in ladder structure, the topmost ladder is being differentiability, the middlemost is being continuity, and the least one is being limit. So if it is been continuous, by default the limit do exist. If it has been differentiable, by default it has been a continuous as well as the limit do exist. If it has been a continuous, by default limit do exist, or it may or may not be differentiable in nature. Did you really understood what exactly I wanted to communicate? I had taken the next problem as well. See what had been happening. The function has not been continuous at this point, and as it had not been continuous at x is equal to c, by default it won't be differentiable as well. And at the same time, the limit do exist because there had not been any sudden change at x is equal to c. If you approach the function from left hand side or right hand side, you might be reaching to the same point. There had not been any abrupt change, and as there had not been any abrupt change, forget about the non-existence of the limit. Limit do exist happily. The same with another function. The another function is being taken as 1 for x lesser than c and 2 for x greater than equals to of c. So this has been a type of step function which we had been drawn over this board. My dear friend, what had happened? at x is equals to c minus and c plus. Or I would say, as you have been approaching the given function from a left hand side and right hand side, you found the value has been what? Towards left hand side, and it's been 2 towards right hand side. There had been a sudden change, and as the limit do not exist, what did actually mean of it? That means in this ladder structure, if you could not claim over the limit, obviously you won't be reaching to the continuity as well as differentiability. But all the way, if you had claimed to the differentiability, by default you must have been claimed to the continuity as well as limit. By default it would be continuous as well as limit do exist. So this kind of the problems are being continuously asked in GATE examination in a theoretical manner. So obviously you should have a little bit idea about it. If the function has been differentiable, by default the continuity and limit test is been okay. If the function is been continuous, the limit test has been okay, but we won't be able to comment about the differentiability. It may or may not be differentiable at point of interest. If the limit do not exist, what I'm saying, if the limit do not exist, by default the continuity and differentiability test has been ruled out. It's been discarded. If the limit do exist, I won't be able to comment over the continuity as well as differentiability, because you yourself must have been seen it here. The limit do exist, but it had not been continuous, and hence it is not been differentiable. And here you can see limit do exist and the function has been continuous as well as differentiable. Limit do exist, the function was continuous but not been differentiable. So I would say, once you have a function in your hand, try to figure it out how graphically it looks like, and with the help of graph easily you will be able to find out the 3 important tests which had been conducted in today's class, and that has been limit existence, continuity and differentiability. If the cusp formation has been taken place and function has been continuous, cusp formation has been created and function has been continuous, no pen is been lifted while draw this curve. Obviously it is been a continuous, but as the cusp has been created, I won't be able to draw a unique tangent at the point of interest. I won't be able to get its slope, and hence the differentiability test has been failed. Did you really learn what exactly I wanted to communicate over here? So let me do one thing. Let me take few number of mathematical functions, because graphically the things are being clearly known to us. So I think it's been the right time I should also be taking few number of functions. Few number of functions. So let me copy this down. So rather giving the graph, I would be giving a mathematical function, and taking the reference of that mathematical function, you had to comment over this 3 important tests. So let me copy this down. Let me copy this down. So here comes the next question. Here comes the next question. Let's take, we had a single independent variable function f of x, and that has been defined as the absolute value of x or mod of x. Tell me at x is equals to 0, that has been a point of interest. Out of the 3 number of tests, which are been the tests are been successfully and which are been failed. Yes, this has been x-axis and here goes y-axis. Probably I understand you must have a little bit idea about mod of x. How the mod of x looks? It looks something like V shape at x is equal to 0. If you don't understand, you can do one thing. You could have taken alternate method as well. See what had been happening? Whenever you have been dealing with a modular function, no, you can take its alternate. And that has been the best alternate according to me. Again, I would be taking xy plane. Here comes y-axis. Here goes x-axis. So it's been the x-axis and it's been y-axis. Don't focus over the modular function. Just focus over the function which has been inside the modular, and that has been y is equals to x, and that has been a straight line, slope is equals to unity and crossing through the origin. So how the structure is going to be? The structure is going to be something like this. So this has been the structure. Yes, sir. May I know which function it has been? It has been y is equals to x. Y is equals to x. What the modular function does? If you have been dealing with a complex number, the things have been quite different. But if you have been dealing with a real number, and obviously it has been a pure real number only, because x would take all real values, and even the function has been crafted in such that it won't be complex at any cost. So obviously one thing has been quite sure, function x or y is equals to x would be taking all of the real values only, and once you take the magnitude or the mod or absolute value of any of the real quantity, what happens? The negative sign becomes positive and positive remains positive. See what had been happening. In first quadrant, the y has been already positive, so taking modular hardly makes sense. So what had been happening? this curve would remain as it is. Either you take y is equals to x, either you take y is equals to mod of x. Agreed, sir. But towards left hand side of x-axis, or I should say towards the negative value of x, the value of y has been negative. And as the value of y has been a modulo of x, x could be negative, but y can't be negative at any cost. Even if x has been minus of 2, y has to be supposed to be plus 2. If x has been minus 3, it's supposed to be plus 3. So what had been happening, it would be flipping, taking the reference of x-axis. And if it would be flipping, taking the reference of x-axis, the structure would look something like this. And now, if you will pretend what had been the new structure. So obviously, so the new structure has been kind of this. New structure has been kind of this. This one. And this has been the same, which comes along with the y is equals to x. Y is equals to x. Mathematically, this has been y is equals to x. But here what had happened? The slope had been just reversed. Initially, the slope has been plus 1 and now it has been minus 1. So it has been y is equals to minus of x. So as far as the mod of x is being concerned, mathematically it could have been written as minus of x when the value of x is been lesser than 0, plus of x when the x is been greater than 0. Agreed, sir. Greater than 0. Agreed now? Yes. And even you can see, if we'll feed x is equals to 0, even the minus of x gives the same value as the plus of x gives. So even we can take a equality sign as well. That means the worth of the function at x is equals to 0 has been quite unique. Either I take the reference of f1x or f2x, and that is why equality sign is also been associated with lesser than and greater than. Now I would like to know from each one of you, my point of interest for this given question has been x is equals to 0. Until and unless the point of interest is not been given, you should not be commenting over the continuity, differentiability and existence of the limit. Let's take the point of interest with x is equals to 0. Tell me, out of 3 number of tests which has to be conducted, limit, continuity and differentiability. Limit, continuity and differentiability. What must be your response? Whether the limit do exist, whether it's been a continuous, whether it's been differentiable. Tell me. I would like to know from each one of you. Limit, yes, a limit do exist as I come from the left hand side, reaches to the x is equals to 0, either comes from right hand side, reaches to the 0. By default, they had been reaching to the same worth and that is been 0. So obviously the limit do exist. Continuity, yes sir, pen has not been lifted while drawing this V shape, it is going to be continuous in nature. If we'll talk about the differentiability, sir, the cusp has been formed. I won't be able to draw any of the unique tangent at this point. Obviously, if you won't be able to do so, you won't be able to do so. Obviously, it is going to be differentiability. No, it won't be differentiable. You won't be able to draw any unique tangent. Even it could be a tangent, it could be a tangent, it could be a tangent. No unique tangent, and by default, the differentiability test has been ruled out, is been failed. So if I'll say it has been mod of x. Thanks, dear. Yes. So, yes, obviously, it is not been a differentiable. Let me do one thing. Let me take another question as well. I would change the structure of this problem a bit. Rather taking the modulo of x, I would take a modulo of x plus 1. This kind of questions are being repeatedly asked in different stream of gate. So, what's the basic difference I had been creating? Rather taking mod of x or magnitude of x or absolute function of x, I had taken this as mod of x plus 1. Mod of x plus 1. And now my point of interest is being changed from x is equals to 0 to x is equals to 1. My basic focus has been x is equals to 1. And again, the 3 important tests is to be performed, and that has been the limit test, continuity test and differentiability test. Again, the same thing has been happening, my dear friend. What I am saying, first you have to draw x plus 1. How the x plus 1 looks like? What you do, you take y is equals to x plus 1. The best way to draw any kind of linear function is to find the intersection over the x-axis and y-axis. My dear friend, at y-axis the value of x is being 0, and similarly at x-axis y is being 0. Why is so? My dear friend, as you go upside or downside, the value of y increases and decreases. If you have been lying over the x-axis, obviously the value of y has to be 0. So what I'm saying, the value of y is being 0 at x-axis. And same goes over the y-axis. If you displace this towards right hand side, value of x increases. Towards left hand side, the value of x decreases. But precisely at y-axis, neither you have gone towards right hand side or left hand side. So obviously the x has been 0. So what I'm saying, you just feed x is equals to 0. Why so? Because x is equals to 0 is nothing but y-axis. So the first point is going to be feed x is equals to 0. Once we feed x is equals to 0, we get y is equal to 1. So I could get the intersection of this linear equation over the y-axis, and that had been at x is equals to 0 and y is equals to 1. The same goes with the x-axis as well. For the x-axis, what I would do, I would keep value of y as 0. And once I keep value of y as 0, you yourself would be able to understand x has been found to be minus of 1. X has been found to be minus of 1. So let me do one thing. Let me rub this down. Just a minute. Let me rub this down. Yes. Let me rub this down. Yeah. So intersection points are being 0, 1. Y-axis at y is equals to 1. So somewhere here it is been 0, 1. And same it has been at minus 1, 0. The x has been minus 1 and y has been 0. So obviously it would fall over the x-axis. Again, I would draw y is equals to x plus 1. So this has been the curve now. This has been the curve now, which would pass through, just a minute, which would pass through these 2 points, and this has been the curve of y is equals to of x plus 1. What I am saying, this has been the curve of y is equals to x plus 1. But my basic concern is not been y is equals to x plus 1. My basic concern has been y is equals to magnitude of x plus 1. What does it actually mean of it? Whenever the y becomes negative, I had to take its positive value for the time being. If x has been 0, 0 plus of 1 is been plus 1. If you will take even its magnitude, still it has been 1. So what I am saying, till this point, no, or I would say from x is equals to minus 1 onwards, the function has been positive. How it has been positive? It has been drawn over y is equals to 0 or above x-axis. There would not be any change at this moment of point or at this portion. Sir, when modulus function is opened, we take plus and minus sign both. But why we are taking just plus? That is x. Will show. Yes, I will show you. I will show you. No issue. Anyways, what has been your name? DPK. So just try to understand what exactly I wanted to communicate. So DPK, may I know exactly where the change is supposed to come? The change would not come from x is equals to minus 1 onwards, because already the function has been positive. If you will take its magnitude, it still hardly makes sense. But what had been happening, towards left hand side of x is equals to minus 1, wherever the value has been negative, let's take if the magnitude has been minus 1, it would be shifted to the plus 1. If it has been minus 2, it would be shifted to the plus 2. And virtually speaking, the new structure is going to be something like this. New structure is going to be something like this, yeah. Yes, it had been something like this. Now the two important changes are being taken place. May I know what are they? First, the slope is being changed. What had been the initial slope? If you will try to find the slope of x plus 1, you take its differentiation, and that has been plus 1. Here the slope is been plus 1. What I am saying, here the slope has been plus 1. Even still the slope has been plus 1. But here now it had been changed to the plus 1 to the minus 1. And as the slope is being changed, obviously plus x would become minus x. Plus x would become minus x. Yes, and at the same time what had been happening, rather striking 0, 1, it would strike 0, of minus 1. So the interception over the y-axis is also being changed. And interception over the y-axis is also being changed. The value of c would also be inversing or reversing its value. So may I know what had been structure? So you yourself would be able to understand, sir, there had not been much difference. First of all, the point of change has been x is equals to minus 1. X is equals to minus 1. Before x is equals to minus 1, and after x is equals to minus 1. See, after x is equals to minus 1, the curve is just been overlapped over x plus 1 only. So yes, this is been x plus 1 only. X plus 1 only. But if you'll go towards left hand side of x is equals to minus 1, what had happened? The slope has been reversed. Initially it has been +1, it has been -1. Initially it was attacking 0, 1, and now it has been attacking 0, -1. So obviously the polarity of x would also be changed and polarity of constant would also be changed. And this has been -x, -1, or partially you can write this as minus within the bracket x plus 1. Minus within the bracket x plus 1. And this has been your function. Yes. Anyways, let me focus over the test now. Existence of the limit. Limit do exist? My dear friend, my test point is x is equals to 1. It has not been x is equals to -1. So my test point has been somewhere here. That is why deliberately I have chosen x is equals to +1. Because the student think wherever the cusp has been formed, there only usually the test point used to be. No. By at x is equals to 1, you yourself would be able to understand there had not been any sudden change. If you will start from left hand side and if you will reach to the 1, if you start from right hand side, if you will try to reach to 1, you will be reaching to the same magnitude. And may I know what would be that magnitude? If you will feed x is equals to 1, it becomes 2. So yes, you are been reaching to the same magnitude and that has been 2. The limit do exist, my dear friends. Limit do exist. If you focus over the continuity, so what had been happening, whether it's been the continuous, obviously while draw this curve, I did not left my pen or I did not leave my page, so obviously it's been a continuous. Whether it's been a differentiable, there had not been any formation of curve, the curve is been smooth, it has been a differentiable. It has been a differentiable. Anyways, the student who have been live, I would like to ask a question from them. Again, the function has been same. The f of x has been taken as a modulo of x plus 1. But the point of interest has been changed from x is equals to 1 to x is equals to -1. Tell me, out of 3 number of tests which have been failed and which have been passed, the limit do exist or not, whether it's been a continuous or not, whether it has been a differentiable or not, whether it's been a differentiable or not. Obviously, sir, the limit do exist. Limit is still exist. What I'm saying, limit is still exist. And then comes continuity. Continuity still exists. Now the differentiability test has been failed. Differentiability test has been failed. So this has been the outcome. This has been the outcome. Now what I would do, let me give you a short trick. If you had any modular function which has been applied over a linear polynomial, let's say you had a function y is been ax plus b, where the a and b are being the coefficient which are being purely real in nature. Obviously we had been dealing with a real function, purely real in nature. They could be positive and negative, that solely depends on the different problem. May I know where the change point is supposed to come? My dear friend, at magnitude of x, the change point had come at x is equals to 0. And similarly at magnitude of x plus 1, the change point is been at x is equals to -1. And hence for the magnitude of ax plus b, the change point is going to be, you have to compare this with 0. Because 0 has been the change point. If it has been greater than 0, it would remain as ax plus b. If it has been lesser than 0, it would become minus ax minus ab. So what had been happening over here? So we will compare ax plus b is equals to 0, and here it becomes x is equals to minus b by a. So keep in mind the change point would always be minus b by a. Change point would always be minus b by a. So virtually speaking, taking the reference of the given function, and that has been the modulo of ax plus b, I could have written this as modulo of ax plus b is equals to minus ax, the slope has been reversed, and even the interception over the y-axis is also been reversed. And that has been the case when the x is been lesser than minus b by a. And here it becomes ax plus b minus b by a. So from here onwards, nobody should have any kind of doubt. If you had been dealing with a linear function, straight away you can do so. Let me do one thing. Let me take a function now. And taking the reference of the shortcut which we had deduced in last page, the analysis would become much easy. Let's take it has been 2x plus of 3. 2x plus of 3. Anyways, the student who have been live, I would like to know from each one of you where the cusp would be framed. At which value of x the cusp would be framed. I would like to know from each one of you. It's quite easy, my dear friend. Just do one thing. Let me draw xy plane. Here comes x axis, here comes y axis. Quite okay, sir. X and y axis are been there in front of you. What you had to do, you had just to compare with 2x plus 3 with 0. So the value has been minus 3 by 2. So minus 3 by 2 would come towards left hand side. Yes, no? Yes. So x is equals to minus 3 by 2 is been a point where the changeover is going to take place. Where the changeover is going to take place. Towards right hand side, it would be increasing, and towards left hand side, it would be decreasing. It would be decreasing. If you wants to know what exactly the curve, a mathematical curve could have been written over here. So this must have been 2x plus of 3, and here it must have been, as the slope has been changed and even the strike over the y-axis is also been changed, it's been minus 2x minus of 3, minus 2x minus of 3. Yes, no? If I say my point of interest is been at minus 3 by 2, tell me about the behavior of this function, whether the limit do exist or not, whether it's been a continuous or not, whether it's been a differentiable or not. Yes, limit do exist, no doubt. Limit do exist. If I'll focus over, if I'll be focusing over continuity, yes, it has been continuous. It has been continuous, but as the curve formation has been taken place, it is been differentiable. No. See, so far I was trying to extract this 3-many test. What I'm saying, so far I was able to extract, or I was extracting this 3-many test with the help of graph only. But over the period of time, you might be dealing with few critical functions where the draw of graph won't be easy. And there, what you had to do, you had to develop a mathematical calculation, or with the help of mathematics, I must be able to conduct this 3 test, and that would be my area of concern in future. That would be my area of concern in future. In future, yes. Agreed, my dear friend. Till this point, I don't find any of the student would have any kind of doubt. Any kind of doubt. If you guys are having any kind of doubt, you can ask over the digital board. Anyways, let me draft a question for you guys. Y is equals to, or the function which carries one independent variable x is being 2x plus 3. 2x plus 3. And let me do a little bit change in this problem. Rather taking 2x minus of 3 we had taken. Tell me in which critical point the function will be non-differentiable. I just wanted to know the value of x, non-differentiable. That has been area of concern in today's class. That has been the first question. Now in second question, let me focus over another function again which carries one independent variable, and that is being taken as magnitude of x square. Magnitude of x square. What I am saying, it has been magnitude of x square. Then goes. Just a minute. Anyways, these have been 3 questions which I had given as a form of homework. So you had to smash this problem out. You had to smash this problem out. Agreed, no? So this is all about the today's class. Okay, so I had also had a Telegram group. If you guys are been interested taking this notes, you can join the Telegram group. Let me send this PDF to the Telegram group now. So here, and here comes the Telegram group. So let me share this down. So I've been sharing this. So you guys have joined our Telegram group or not? I would request each one of you, try to join as much as fast possible. This PDF has been sent now. Okay then. This is all about today's class. We'll meet next class. Till then, bye bye. Take care.